So thank you so much, Maria. And also from the Oracle database team, we have Shin, which is in the Oracle Graph and Spatial. So I would love that you tell us a little bit more about your work in the Oracle database Graph and Spatial area, and also what is the thing that you think is more interesting out there, or you love it more this year of the things that you have been working with Oracle technology.
Sure, great. Thanks, Adel. It's really an honor and a pleasure to be here today. And I am on the product management team for Oracle's Spatial and Graph Technologies, and we're part of the overall Oracle database organization, like Maria. I work on various outbound product management and product release activities. And as mentioned, one thing I do enjoy is serving as an Oracle advisor and collaborating with you and Abby and the rest of the fantastic team on the A&D Oracle user community. So yeah, I'll start sharing my screen right now.
Perfect.
And today, the favorite technology that I'm going to highlight is graph technologies. Graphs are a super powerful emerging tool for your analytics toolkit. And I think some folks may have heard of it, some may not be as familiar with it. So I'll talk about why it's so compelling. And I've been having a little bit of instability in my internet connection. So for now, I'll stop my video while I'm sharing here. I'm actually filling in for my colleague, Melli Annamalai, who couldn't be here at the last minute. So thanks to Melli for some of this great content. So let's talk today about the connections that you have in your data and how you can make use of those connections to get new insights into your data. All data has connections and relationships, but typically those relationships tend to be implicit. And the power of graphs is they allow you to make these connections explicit, and you can analyze and view your data in many different ways. Data is an organization's most valuable asset, and we really want to look at getting all the value we can out of the data. So starting with a simple example, we have a few rows in this table. A, B, C, D, E, F, and so on are the entities. The connections between these data entities is captured in the depends on column. So by checking out the first row, we can see in the depends on column that A depends on B, likewise that B depends on C, and so on. But when we want to ask the question, does A connect to F? It's not easy. It's not immediately evident what the answer is. But if we model the data as a graph, we can instantly see that A is connected to F. By traversing these explicit connections or links, starting from A to D to E to F, we can easily see that A and F are connected. What are some other questions that we can answer with this graph model? Let's take a look at I. If we want to know what incoming nodes are to node I, we see that C, G, and H all connect into I. But the interesting thing about graphs is you don't have to stop with these direct connections. You can also find indirect connections, like in this illustration. So E and F also have incoming connections to I via intermediate nodes, so over multiple hops. And you can also see that E is connected to I in more than one way. We can jump from E to G to I, or jump from E to F to G to I. And so E is connected to I by either 2 or more hops. And so on. We can keep looking for indirect connections to I, and we can see that eventually nodes C and D, and actually A and B, are also indirectly connected to I. And these types of insights have all kinds of powerful and interesting applications in a variety of industries, from financial services to manufacturing to the public sector and more. So when you're working with an application, you'll typically have data in tables, and you'll need to represent that data as a graph. Here we have movie rental data. The tables have information on customers, on movies, and on which customer rented which movie, which is reflected in the has rented table. Customers and movies are data entities in the data set, and they naturally become nodes in the graph. And the information about which customer rented which movie would be a relationship between the customer and the movie, and it's represented as an edge in the graph. And this graph can be used to make movie recommendations by analyzing which customers are connected to each other by the movies that they like to watch. This bank graph example includes a table of bank accounts and a table of cash transactions between those accounts. And bank account holders are naturally entities. And whenever a bank account transfers cash to another account, that's a relationship between those two accounts. And that relationship gets modeled again as an edge between those two accounts. And this type of graph can be used for things like uncovering fraud by detecting cycles like circular money transfers, or by identifying unusual patterns. And you can create a graph from virtually any data set because any data set has latent connections. And Maria talked about JSON and relational duality. And in these examples, we're seeing that the same data set can be stored both in relational tables and represented as graphs. Let's take a look at an example of how graphs can enhance machine learning algorithms in this example of making product recommendations. So here, products are recommended to customers by identifying other customers who have similar interests. So the idea is that customers that have similar interests, the ones who like the same movies, the same food, may tend to like and purchase similar products. Now, when we add graph to that mix, we can view this customer Maya in the context of the network of her connections. So she may be interested in products that her friends buy, but she may also be interested in products that the friends of her friends purchase. This type of graph allows us to do analytics on a customer's network of friends, family, colleagues, acquaintances, and derive a fuller and maybe more accurate set of product recommendations, based on these connections and the behavior of folks who are 2 or 3 hops away in her network. So graph analytics makes it possible to include information based on these connections and relationships in data and feed it into a machine learning algorithm. You can model the data as a graph, run the graph analytics algorithms on the graph, and then include that info as input to the ML algorithm. So when you analyze your data as a graph, you can do things like detect communities of users, enhance machine learning algorithms, and find important and highly connected nodes. And there are graph theories that have many rich algorithms, and you can apply those to your graph data model. You can also query a graph by using the property graph query language. This is a SQL-like query language, and it allows constructs like select, from, and so on. And it also gives you the capability to specify a graph pattern. You can run different queries to do things like find cycles, find paths, find the shortest path, find the top 5 shortest paths, and so on. And typically, you'll want to work with visualization tools to visualize the data in the context of your graph, or you can use the results programmatically. And Oracle Graph has all the tools that you need to work with graphs. We're available on all database editions, on premises, in the cloud, and with features like Graph Studio in Autonomous Database, we really make it easy to get started with graphs, with automated graph modeling and an integrated notebook with visualization. We also support popular tools like SQL Developer and enable those to work with graphs. And finally, one exciting upcoming development in the next database release 23C, we actually plan to support graphs directly in SQL. So you won't need to use the PGQL language. You can do all your graph operations in SQL, and all your graph development environments, all your SQL development environments and tools will work with graphs. So that will make the learning curve even smaller and make it super easy to integrate graph into all your applications. So actually, just a final comment, aside from graphs, Melli and I are just really proud that women have played a key role in many of aspects of bringing this technology to Oracle. We're actually proud to be a part of a product management team that's 50% women and 50% men. And overall, in the database product management organization, there are many talented and accomplished women like Maria and others, many in leadership positions. So we're just happy to be part of this thriving environment of women in technology. So Adel, thanks very much, and I'll hand it back to you.
Thank you so much, Shin. And Graph, I didn't know about that in 23 version you're going to use SQL directly with Graph. PGQL is easy, in fact, to learn it, but even the possibility to use SQL directly, it's amazing. Thank you so much for this.